All right, I'm back and I'm going to take a look at a couple more of these things. So it's going to be the same basic idea. It's very helpful if you know how polar curves are traced out so that you can identify what the origin is in these pictures. That's like really the key thing, right? So I look at this thing and I know that the origin should be right through here. And I know actually that this is a cardioid. So depending on how familiar you are with cardioids, you can already say that this is going to be 3 plus 3 cosine of theta. How did I get that? Well, I got that because this distance right here is 3, predominantly on the positive x-axis. So it's going to be a positive cosine. And when you're at pi over 2, cosine of pi over 2 is 0. So I knew that this value of 3 was like a. So it's going to be a plus a cosine. So I know that this is actually r equals 3 plus 3 cosine of theta. So let's say you didn't know that. If you don't know that, now you're in the position where you're going to find your values. So this distance is 6. So you know that if we made a table of values where we have theta and we have r, when theta is 0, r is 6. When theta is pi over 2, r is 3. When theta is pi, r is 0. 3 pi over 2 is going to give you 3 again, and then 2 pi would give you 6 again. If you plot those, you will see that it is definitely the curve 3 plus 3 cosine theta. So it's helpful to recognize these patterns. I mean, that's why you want to know the common curves, because then you're able to just utilize them to write your equations. And some people will know them faster than other people. That's okay. Just make sure all of the techniques are kind of like at your disposal so you can do whatever you want. This point right here is -2, 4. And so we can write our equation. So it's going to be, almost dropped my iPad there, x equals y equals, so we said -2 and 4. What in the world? Oh yeah, -2, 4, sorry. I was looking at the wrong thing there. And then plus quantity, 3 plus 3 cosine theta, and then cosine theta. So x always has that extra cosine theta, and it'll be plus 3 plus 3 cosine theta. Right, that's r, and then sine theta. And there you go. Sometimes when I write these, I leave out parentheses. Then when I look back, it always annoys me. I'm not going to be able to squeeze them in, though, for that polar curve. So that's my equation. So I did that by just recognizing what was going on. The next one, I think I can also do that, but instead, I'm going to actually show the work. As I discovered last time, I can move myself around. That's weird. So let's see what we can do here. So I actually had to give you the center here because, well, I didn't have to give you the center, but I had to give you like the vertical points so that you could find the center because it's not really obvious when you're looking at these. So like off the top of my head, I'm looking at this and I know that this is going to be a negative cosine. I know that the constant is going to be bigger than the coefficient because there's no inner loop. But I'm going to work it out the way that I have been working it out, where I'm going to make a table of values. So I'm going to say theta and then r, right? So it's always the distance from where the origin should be. So like this distance is 1. So when theta is 0, my radius is 1. And then when theta is pi over 2, I'm going to be up here, and this distance is 3. And then when theta is pi, I'm going to be this distance, which is 7, I think. And then 3 pi over 2, I should be 3 again. Oh, and I'm 4. 1, 2, 3, 4. Yeah, I just counted that wrong last time. Let me erase that and go with 4. And then, yeah, I'm 4 away. Okay, so what rectangular curve would go through these values? Okay, so you're at 1. and then you go up 3 to get to 4, and then from 4 you go up 3 to get to 7. So 4 is the middle number, so I think you're going to be at 4 minus 3 cosine theta. So let's plot these and see what we get just in case. Doesn't need to be perfect, you just want it to be kind of nice. Actually, so I don't really need that. Okay, so it's going to be 4, 7, and then 1, 1, 4, 7. All right, so when theta is 0, you're at 1, then here, then here, then here, then here. I think we can pretty confidently say that that is a really bad graph. It's not even a graph, it's a bunch of points. Well, I mean, a bunch of points is a graph, but we want the continuous function. So this is definitely r equals 4 minus 3 cosine theta. And then our origin was shifted to 5, 4. This is a mess. Is this causing me to have more empathy for people who complain about not having enough space in the notes? Maybe. I do think you have the advantage of you don't have to like scroll all over the place. But yeah, I mean, I hear your complaints. They're valid. I'm gonna validate those for you. All right, so x equals y equals. All right, so 5, 4 is our center. 5, 4 plus quantity. Let's go back to this. 4 minus 3 cosine theta. And then this is annoying. Cosine theta. The switching colors is annoying. But I'm committed to it for this particular problem. There, and then still 4 minus 3 cosine theta because that's r. That's our polar curve that we're shifting. And then sine theta because we're converting it to parametric so that we could move the center around. Okay, so I think I'll actually stop that one there. And I'll come back in another video and probably do some more of these. So I will see you then.